Okay, this is your Unit 8 Chapter Test Review. Number 1. What is the length of a diagonal brace that could be used for a wall 6 feet high and 8 feet long? Okay, we're looking for the length of the diagonal brace, so let's make that X. We're told that the wall is 6 feet high and 8 feet long. And this looks like a right triangle, so I can use the Pythagorean theorem. So we'll put 6 squared plus 8 squared equals x squared. That's 36 plus 64 is x squared. 36 plus 64 is 100. Plus x squared. If we square root both sides, x equals 10. Number 2. Jean's horse corral, labeled A, B, C, D in the drawing, is shaped as a parallelogram and is adjacent to the shed, labeled G, A, D. If a gate labeled CF over here opens all the way to the corral fence, position labeled CG, how many degrees does the gate swing? So we're looking for the size of this angle over here. Well, if this is a parallelogram and this is a right angle here, we know that this is 40 and this is 90, so if we add 40 plus 90, that gives us 130, and this triangle is 180, so if we do 180 minus 130, gives us 50 left over, so 50 will go right here, and we know that this is a linear pair, so this angle here is going to be 180 minus 50, which is 130, so 130 is going to go right here, and if 130 goes there, it's also going to go across here. So our answer is 130. H. Number 3. A diagonal of parallelogram DEFG forms angles with the measures as shown. What is the measure of angle DEF? DEF over here. Well, if this is a parallelogram, we know these are equal. So if we find this angle here, we'll find angle DEF. So triangle is 180. So far we have 56 plus 44, which is 100. Subtract that from 180. And that gives us 80 for this angle here. So your answer is C. Number 4. A baseball diamond is in the shape of a square 90 feet on a side. So there's 90 feet, 90 feet, 90 feet all the way around. What is the direct distance from home plate to second base? So here's home. Second here. This is X. So it looks like we've got a right triangle problem here again. Each of the legs is 90, and the hypotenuse is X. So we'll do 90 squared plus 90 squared equals X squared. Okay, so if we put 90 squared plus 90 squared in our calculator, we get 16,200. 16,200 is right here. And that is x squared. Now if we square root both sides, that gives us 127.27 for x. Now, none of these match. We know it's not 90 feet. We know it's not 180, so it's going to have to be one of these two. So all we have to do is plug those in the calculator and see which one matches that. First one is 90 times the square root of 2 And that's the answer. Our answer is G. Now, if you remember our special right triangles, you'll know that if this is 90, these two are both 45. So this is a 45, 45, 90 triangle. And the hypotenuse is going to be the square root of 2 times one of the legs. So you could have found it that way if you would have remembered that. So either way, your answer is G. Number 5. What is the value of x in trapezoid ABCD? If this is a trapezoid, we know a trapezoid has one pair of parallel lines right here. And if this is a right angle, this is a right angle, and this is a right angle, we know that this is a right angle up here. So we've got a rectangle, and opposite sides of a rectangle are congruent, so we can just do 20 equals 2x plus 6, and solve for x. 14 equals 2x, therefore x equals 7, and that's what we were looking for, so our answer is D. For 6, quadrilateral MNOP is a parallelogram. Coordinates of 3 of its vertices are M, N, and O. Coordinates of P, what is the value of x? Okay, so if this is a parallelogram, it means opposite sides are parallel. So here are 3 of the vertices, so we're going to find out where P goes over here so that we'll have a parallelogram. So if we go up 1, 2, 3, 4 and back 1, the slope of this line, side over here, is going to be 4 over -1. So we're going to do the same on this side. 1, 2, 3, 4 and back 1. And those are going to be our coordinates of P. And the coordinates of P are -4, +2, and we're looking for the x coordinate, and that's going to be G, -4. And that's number 6. Number 7, PGRM is a parallelogram with diagonals PR and GM that intersect at point A. GA is 2x, so 2x goes here. MA, right here, is 3x minus 4. And PR, this whole distance is 5x. Find the value of PA. Well, if this whole distance is 5x, we know that this is going to be half of that, which is 2.5x. And that's what we're going to have to find over here. So first let's solve for A. We know that these bisect each other, so these two have to be equal, so we'll do 3x minus 4 equals 2x. Let's subtract 3x from both sides. And those are gone. I've got -4 equals -x. If -4 is equal to -x, positive x must be +4. So x is 4. We need to find the value of PA. PA is 2.5 times x, so PA is 2.5 times 4, which equals 10. That's number 7. Number 8. RSTU is a rectangle. SH is 2x minus 5. RT is 32. Find the value of x. So SH right here is 2x minus 5. RT, the whole distance here, is 32. Put 16 here, 16 here. And we know that since this is a rectangle, all of these segments are congruent. So we can just do 2x minus 5 equals 16. We're going to add 5 to both sides. 2x equals 21 divided by 2. X 9. JKLM is a rectangle. If the measure of LJM is 63, find the measure of each angle. Okay, so when you have a problem like this with multiple answers here, we usually like to go ahead and find all the angle measures in here first, and then we'll just transfer them over here. So first of all, let's make this pen a little bit thinner. LJM. LJM, I just went around this angle, that's 63. Now, since this is a rectangle, we know that these are all the same. So we have isosceles triangles there. If this is 63, so is this. We have our Z here, so this is 63, and this is 63. We know that each of the corners is a right angle. So if we do 90 minus 63, it gives us 27 for this angle, 27 for this angle, 27 for this angle, and 27 down here. Now to find this one right here, we know the triangle adds up to 180, so if we add 27 plus 27, that gives us 54. And we're going to do 180 minus 54, and that is 126. So 126 goes right here. And 180 minus 26 would be 54, so that's going to go here. And 126 and 54. Now we have all our angles filled in. Let's find the measure of each of them. KLM. KLM. Okay, we outlined this whole angle here, so 63 plus 27 is 90. So, hold on, we're looking for KML. KML. KML outlines this angle, and that's going to be 27. That's 27 degrees. JPK. JPK. We just went from around this angle here, so that's going to be 126. KPL. KPL is 54. And that is number 9. Number 10, ABCD is a rhombus. ABCD is a rhombus. Angle A is 75. Find the measure of angle B. Well, if it's a rhombus, it's also a parallelogram. And we know that consecutive angles are supplementary. If we're looking for this one over here, we're just going to do 180 minus 75. And that gives us 105. So the measure of angle B is 105 degrees. Number 11, ABCD is a rhombus. Angle A is 120, so 120 goes here. Find the measure of angle CBD. CBD, we're looking for this angle up here. I'm going to put X right there. So, it's got 120 here. This is going to be 120 over here. Let's see, it's a rhombus. Okay, so that means opposite angles are bisected. So if this is 120, and this is X, this is going to be X here. This is going to be X here, because these are the same as an isosceles triangle. So let's do 180 minus 120. That gives us 60. And two angles would equal 60, so 60 divided by 2 equals 30. So our answer is 30 degrees. There's a little typo here. We said find the measure of CBD, and down here it says CDB. Well, CBD and CDB are the same thing, so they're both 30 degrees. And number 12, ABCD is a rhombus. ADB is 41. ADB is 41. Find the measure of CEB. CEB, we're looking for this angle right here. Well, it's a rhombus, and we know the rhombus has 90-degree angles in the middle, so CEB is 90 degrees. And that is number 12.